Hello everybody, my name is Cheryl McLean. My group member is Celine Sarkislo, and this is our MATLAB project for numerical methods at Cal State LA. The project is Numerical Methods for Engineers 2, and it's project 2, and it's 2D finite difference analysis of heat transfer in a plate. So in order to run this project, you need your data text, and that is the most important part. Your data text, it could be infinite amount of rows, however, each column within the line represents a certain value. So as you can see in the first line, you have 0, 0, 0.010, and then 0, 2, 0. So the first 0 is your x1, and your second 0 is your y1, and that represents the beginning of a line. And the end of the line is followed by your x2, y2, x being 0.010, and y2 being 0. Your fifth line represents boundary conditions, and it starts from 0 and it ends to 5. So a boundary value of 0 is an inactive node, and 1 is active, 2 represents no flow, 3 represents flux, 4 represents constant, and 5 represents convection. Your sixth column represents the information provided by that boundary condition. So let's say you have 3 flux. Let's look at this line. It's going to have the flux value, which is 10 times 10 to the 5th. So this is the data text. This is what the user needs to provide the GUI in order for it to run. So our GUI is final project. We wrote final PO. So this is our script, and if I run it, let's get a fresh one. So we have a browse button. The browse button calls out the file selector, and you can select your file. So I have data text already in here, and it's going to display to you your x1, x2, y1, y2, your boundary condition, and the information, as I said, pertaining to your flux or pertaining to your convection. And based on these boundary conditions, which is your lines, these lines create this shape. So we want to make sure that each node is represented, and the nodes that are not in here, like the node here and the node here, do not show up in your shape. That way it can be a clean shape and showing all the nodes that are actually running through your program. So if I put values for your delta x, 0.025, and I do time analysis, 45, your delta t, I'm going to put a 1, and I'm going to choose bismuth. My calculate button actually outputs a video of heat transfer, and at the end of this video on the third axis is going to show a heat transfer flux vectors. So this is what essentially the GUI does for the 2D finite difference analysis of heat transfer in a plate. As you can see at the bottom right is the heat flux vector graph that I was talking about. Unfortunately, it is not running correctly, and it outputs, as you can see, various vectors in a form of stairs. So this is what our GUI does, and it also outputs this video again of the heat in the shape that provided, and this is our final project, final PO function for the GUI. As you can see, the first thing our GUI script does, it goes through the aluminum, antimony, it goes all through the material from aluminum to zirconium, and it basically sets density, specific heat capacity, and heat conductivity, K. So this is your density, this is your heat capacity, and sorry, this is your specific heat capacity, and this is your heat conductivity. So as it loops from each material, it's giving these three values, so we can use it in our calculate button. And it uses the delta x, which this x represents. It represents the distance between each node, and I named my delta x a capital X, and it changes a string to a number. That way we can use it. And the same thing for time analysis. It changes the string to a number, and for delta t, string to a number. Now we're going to go into our browse button. This is basically what the browse button does. It calls the file selector here, and you can choose the file, and it will collect that name and set it as data. Now data is also globalized, so I can use it in my calculate button. So from data, I get my x1, which is on column 1, my y1, which is on column 2, my x2, which is on column 3, and my y2, which is on column 4. It's gonna get the max data from each, and it's gonna set my columns and my rows in this file, the data text file. My columns is 5 and my rows is 6. So I set my boundary conditions, my boundary and position matrix, as you can see right here, based on the columns and rows. And it's going to loop through each row, and I'm going to plot my shape here. The next function is the calculate button, and it gets all the global, and this is the script that it goes through. I have an A matrix, a C matrix, and I have my Kramer's rule here. This script is used to create the movie, which you can see right here. My second axis is called col_axis22, and this is where the movie function is, and this is the third axis, which is the quiver function that unfortunately is not playing. So this is our GUI function and our initial script. Thank you for watching.